it is a revision what you did in your first year statistics subject. From first year, you are familiar with the concept of population, sample, and some of the method of drawing a sample from the population. So I can say today's lecture will be the revision what you did in your first year statistics subject. First term is population. If you try to relate this term with other subjects, say sociology. In view of sociology, population is treated as number of people living at certain location. That is the concept of population for sociology teachers or anybody who studies sociology. But if you study population in view of statistics, it is little bit different. How it is different, you will understand by looking the definition of population, which is also named as statistical population. Firstly, I define it, and then I will tell you why the difference comes between sociology concept and statistical point of view. In statistics, population is defined as the collection of animate or inanimate objects related to problem under study is considered as population, or more precisely statistical population. You can see now easily the difference between concept of population through sociology and through statistics. Why this difference is coming? It comes due to the study domain of the subject. When I speak for sociology, it is treated as science of society. And when I speak as a society, society forms by many families stay together. And families formed by the people, maybe male, maybe female. And that is why if you look, the element under study for sociology is a human being. Under sociology, we study all different type of concepts, problems, traditions, cultures, marriages. All these human related problems are studied by sociology. That is why they define population as collection of people. Whereas statistics, if you want to define a statistics from your first year knowledge, I will not say it is a collection of data, it is the arrangement of data in table form and so on. I define statistics as the science of analyzing variation in day-to-day real life problems. So if you want to analyze variation in a real life, you have to study statistics. So variation is very important in statistics subject. Let us imagine any real problem which is free from variation. You can see there is no problem which is free from variation. So variation is the inherent part of the day-to-day life. And that is why I say statistics is important to study in the real life. Because there is nothing without variation. And if you want to study variation, you have to study statistics. So by keeping in this mind, we define population as collection of animate or inanimate objects. Now what do we mean by animate? So animate means everything which is a living. So I will not speak only for people. I can speak for any object which is a living, so I can study statistics there. So my definition of population is a little bit vast. It covers each and everything related to the human being's real problems. Other collection is inanimate. So I can apply statistics for non-living object also. And that is why statistical population is collection of living as well as non-living objects, which covers the concept of sociology also, because animate means living. So you can study human beings, you can study animals, you can study birds, etc. Inanimate, you can study all the production process, everything which is non-living also studied by statistics. And that is the reason through statistics, population is defined as collection of animate or inanimate objects. That depends on your problem, what you are studying. Next, the number of objects which is under your study called as a population size. And usually population size denoted by capital N. So once you have population pre-specified according to your problem, then we go ahead for taking a sample. Now what is a sample? A small group of elements selected from entire population is considered as a sample. Now we know in the real life, by unknowingly, we apply this concept of population, concept of sample. Very simple example. Suppose we go to grocery market and we plan to purchase rice. So in the purchasing rice, what the procedure we follow? We ask the shopkeeper about the price of rice. So he reply as 3 types of rice are available in the shop. So he will say one of the quality is of 40 per kg, another is 70 per kg, and another might be 100 rupees per kg. So then we think a while and we try to decide which quality of the rice is affordable to us. Suppose we pick up rice of 40 rupees per kg. Then what we do? We didn't give the order immediately. We asked him, let us show me little rice to check the quality. Now in this case, the shopkeeper will not take complete bag in front of you. He will take a small pot, and in that pot he will bring the rice. Then by looking that rice, if you like it, you will purchase it. If you didn't like, you will take the another decision. Now in this example, what is available inside the shop in the bag is a population, that is complete rice. And what comes in front of you in the form of little pot by shopkeeper, that is nothing but a sample. So we are using statistics in day-to-day life by unknowingly. So this is nothing but concept of statistics. How to purchase some item in the grocery shop. So what is a sample? It is a small group of units selected from entire population is considered as a sample. The number of units included in a sample is known as sample size. Usually it is denoted by small n. So we denote population by capital N, number of items in a population capital N, number of items in a sample small n. Usually it is found that population size is very large. It may be in lakhs and crores. So why we study sample? Why we not go for entire population? The reason of studying samples are divided basically in three types. Number one, if you try to decide entire population, it will take much more time. Number two, it will take much more manpower. Number three, it will take much more cost to study entire population. So in order to overcome these three things, we prefer a sample. Sample is very small as compared to capital N. That is why by studying a sample, we are saving our time, our manpower, and the most important factor, economy, cost of the survey. And that is why we proceed sample study instead of entire population. But sometimes if government is ready to provide the manpower, to provide the money, and if there is a time constraint is given to you, which is liberal, then you can think to study entire population. And we are doing this. Every decade, every 10 years, we study entire population. And that is called as a census. But there are some examples, even though money is available, manpower is available, and time is also liberal, but we cannot study population. We have to draw the conclusion about population with the help of sample. What are the examples for this? Example number one. Suppose there is a patient which is suffering from a disease which is not traceable without checking a blood. So doctor suggests to that patient, go to the lab and perform the test as suggested by the doctor. So what the patient does, the patient goes to the lab, and in lab, that person took a little part of blood from the body, and by analyzing it, he draw the conclusion about what type of disease that patient carries. Now, in this example, what is the population? Population is nothing but entire blood of the body of that patient. So if you try to study entire blood, I think the patient will not come back. And that is why here you have to rely on the sample, not on the population study. Another example why we go for sample study is the situation of festivals. Now after 1 week, there will be Diwali festival in our country. And in that festival, firing the crackers is one of the vital parts. So if I want to study quality of crackers, which is produced by a certain factory, what will be happen? If I keep on testing each and every cracker, after testing, the dust remains behind. If the cracker gives good noise, I will say good quality. If not, I will say bad quality. But if I apply this procedure for entire cracker produced by that factory, nothing will go to the market. So in this example, you cannot study whole product. You have to decide the quality of whole product by taking a small part from the whole product. Then I will say, suppose I pick up 100 crackers, 100 packets, and that factory produces 1,000 packets per day. So 1,000 is the population and 100 is the sample. After 100, I test them. Suppose I found 78 are of good quality and 22 are bad quality. So I conclude in 1,000, that means remaining product, 78% I can say definitely of good quality. It may be more than that, but minimum good quality is 78%. So these are the examples where you cannot study entire population, you have to study sample. Now the question arises, how to take a sample? I cannot take sample from my side. There should be certain scientific procedure which will help you to draw the sample. Otherwise, if you take a sample from your point of view, conclusion may not be accurate to the entire population. And that is why there are certain methods which help you to draw a sample from the population. And that is called as a sampling. So if I want to define a sampling, I will say the procedure to draw a sample from entire population is known as a sampling. Sampling is a scientific procedure. There are many methods to draw a sample from the population. But as per our syllabus, we are proceed only by 3 methods. Number 1, simple random sampling. Number 2, stratify random sampling. Number 3, systematic sampling. These are the basic sampling methods commonly used in day-to-day life to draw the sample from the population. Let us proceed one by one. SRS. The procedure of selecting a sample by drawing units one by one from the population such that each unit of population gets equal chance to be selected in a sample is considered as SRS. Now, in this definition, this word is very important. Which method is simple random sampling? The method which gives equal chance to every unit of the population to be selected in the sample. So you have to develop the method such that it will provide equal chance to each and every element. That method will be labeled as simple random sampling. We classify this method further in two types. One is named as with replacement. That means simple random sampling with replacement. Other is named as simple random sampling without replacement. What is the difference? If I say with replacement, I select the unit from the population, I make the record, and after making the record, I replace that in the original place of the population. Then I make second selection. And the procedure keep on continue till you get required number of units in your sample. Suppose I study population with 1000 items by taking a sample of 20. So I will make 20 selections one by one. I select one item at the first draw. It may be anything from 1 to 1000. I put it in my sample. I put it back to the population and then I make next selection. So in this method, what is going to be happen? The selected item I am putting back. So there is a possibility to select again the same item in my sample. So for with replacement, same element can be repeated. So number of distinct element is not equal to sample size. It may be sometimes sample size, sometimes is less than sample size. Whereas without replacement, if I have a population of 1000 items, I want to pick up 20 elements by without replacement. So first draw, I will select one item, I make it record, and after making record, I am not putting back, I discard it from the population. And the procedure will be repeated. So basic difference between with replacement and without replacement. Under with replacement, for every draw, population size remain fixed. Whereas for without replacement, first draw population is capital N, second draw population become N minus 1. third draw population become n minus 2. So for every draw, population size gets reduced by one element. That is the basic difference between with replacement and without replacement. Second difference, under without replacement, each and every item is distinct, not repetition. Whereas with replacement, number of distinct items are less than your sample size. Such questions may be asked in your MCQ, multiple choice question. Under SRSWR, sample size are repeated, not repeated, and so on. So there is many possibilities to create MCQ. Now we proceed ahead. In SRSWR, the probability of getting any unit at each draw is 1 by n. That means chance of selecting any unit of population in the sample at any draw is 1 by n. And that I said here, when I define SRS, it is a method which gives equal chance for each population unit. And that is nothing but, if you are studying a population of size capital N, every unit gets chance 1 by n to represent sample. Let us see how to prove it. Whereas in without replacement, the probability of getting any unit in a sample varies from one draw to another draw. This is under with replacement. If I speak for without replacement, first draw probability is 1 by n, which is not coming here. You can make the change in the notes. For second draw, 1 upon n minus 1. Third draw, 1 upon n minus 2, and so on. So chance gets increased as draws are increasing. Firstly 1 by n. For second draw 1 by n minus 1. When denominator is reduced, total quantity increase. So chance increases as draws are increases. Now we have very important question on this topic. In SRSWR, show that the probability of getting, you can read a chance, specified kth unit in a given Rth draw is same as the probability of getting that kth unit in the first draw, and that is 1 by n. Second part of the question, hence find the probability of inclusion of that kth unit in a sample of size n from the population capital N. Try to understand the question and then we'll try to solve it. In this question, what we did, we fixed two things. We fixed the unit and we fixed the draw. kth unit at rth draw. Probability is 1 by n. And inclusion is n by n. Let us check. In SRSWOR, probability, we want probability getting kth unit in rth draw. This is the question what is asked. Selecting kth unit in rth draw. What is the meaning of this? This equal to probability not getting kth unit in previous r-1 draws, because my method is without replacement. That means kth unit selected at rth, that means it is not selected up to r-1, and getting selected at rth draw. So this statement and this statement is equivalent. So that's why I put equal sign. This equal probability not selecting kth unit in previous r-1 draws. Whenever you write and, you write multiplication. So multiply probability of getting it at rth draw. So what is this? It is a product starting from 1 to r-1 of this probability. Multiply probability of getting at rth draw. At first draw, chance of selecting 1 by n, if I say not, 1 minus 1 by n. This is the chance of not selecting at second draw. It is selecting at second draw. 1 minus selecting is a not selecting. Here n minus 1, because method is without replacement. 1 minus 1 upon n minus 2, this is third draw. This continued till r-1 draws. So 1 minus 1 upon n minus r minus 2. How I write r minus 2? Let us see the logic. First n, second n minus 1. When I say third, it is 3 minus 1. Now this bracket is for r minus 1. So r minus 1 is r minus 2. Multiply selecting at rth draw. So it is 1 upon n minus r minus 1. Let us simplify this expression. Number 1 bracket, n minus 1 upon n. Number 2 bracket, n minus 2 upon n minus 1. This is n minus 3 upon n minus 2. Continue like this into the last term. You can see this term cancel with denominator of the next. This cancel with denominator of the next. So by logic, this cancel the denominator of the next. And this cancel with the last term. So what is remain? Only this 1 upon n remain. And that is the first part of the question. Probability of getting kth unit at first draw. So what this proof says? Under without replacement, chance of selecting any specified unit at any specified draw is same as to select at first draw. So according to definition, What is SRS? It is a method which provides equal chance for each and every item to be selected in the sample. That is SRS. Now we want to prove second part of the question. What is the second part? Hence find the probability of inclusion of that kth unit in the sample of size n. See how to develop. Hence, probability including kth unit in a sample of size n. This I want. This equal probability selecting kth unit maybe at first draw, maybe at second draw. Here I write or third draw and continue. Probability of selecting kth unit at first draw plus when I put or, it is a plus. Selecting at second plus so on, probability selecting at kth unit at nth draw, because I want sample of size small n. So I will make n draws. Here we prove selecting kth at first or at any draw is 1 by n. So this is nothing but 1 by n plus 1 by n plus dash dash plus 1 by n. And that is nothing but small n by capital N. So what is the understanding from this? It is the chance of inclusion kth unit in the sample of size small n. Therefore, we proved two things. Number one, probability of getting kth unit at rth draw 1 by n, which is probability of getting kth unit at first draw. Second thing what we proved, probability of including kth unit in a sample of size n, answer is n upon n. Very important derivation. If it is offline exam, this always asked in question for more than 8 marks. And if it is online, there may be question numerical type depend on this result, multiple choice question.